With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? Consider a uniform spherical charge distribution of radius r1 centered at the origin. Now in this distribution, a spherical cavity of radius r2 centered at P with a distance OP is made. So this is our sphere. Here we are making a cavity, okay, at its cavity center is at P and our spherical center is at O. Now A is given as r1 minus r2. So this basically this is the vector which is r1 vector minus r2 vector. Now is if the electric field inside the cavity at a position r, then we need to find the correct statement. Okay, if we take any point inside the cavity, let's say this is the point inside the cavity, okay, at a distance at r radial distance of r. So we can just join this with our radius vector from the center. So basically this is the joining from the center itself. Okay, this is our center joining from the center. So at this point we need to find what is the value of the electric field. Okay, now let's assume that from here to here, let's say that this is the position vector r, and let's say from here to here we say the position vector is s. Then from here to here the position vector would be what? From here to here it would be our a vector, because a is from here to here. So we can write from this triangle that a plus a vector plus s vector would be equals to r vector. Okay, or we can say that our a vector would be equals to r vector minus s vector. Okay, from the triangle, because this and this r is the resultant of a and s. Okay, from the triangle we can see. So we have written r plus s equals to r. Sorry, a plus s equals to r. Now this is a cavity. So how do we deal the cavity type of situation? We first assume that this is a complete sphere having a charge density rho. Okay, this is the volume charge density. Now to treat the cavity, what we introduce? We introduce a minus rho charge density in the spherical cavity. Okay, sorry, not in the spherical cavity, but inside this uniform charge density. So this minus and this plus would be cancelled, and we would be getting a spherical cavity here. Okay, now that means at any radial location there would be electric field due to two things. One, due to this our charge sphere, and this having a charge density sigma, and due to this cavity which is having a treated as a charge having a charge of minus this sigma volume charge density, sorry, rho. Okay, so we can say that electric field due to our sphere of radius r1, this would be given as, how is the electric field given inside a sphere? It is given as rho divided by, first of all we write the formula for electric field inside a sphere. So it is rho divided by 3 epsilon into the distance. Okay, now for the bigger sphere we see that our E from bigger sphere having a radius of r1, it would be equals to rho r vector divided by 3 epsilon. Okay, now due to electric field in the vector form due to r2, this would be equals to rho divided by 3 epsilon. Okay, what is the radius vector? From this center the radius vector we have taken as to be s. So we can say that it would be s vector. Now what would be the value of the net electric field? We take the vector sum. Now here the charge density is minus rho. Okay, so E net would be, we can take rho divided by 3 epsilon from here and here to be common, then it would be just r vector minus s vector. And what is the value of r vector minus s vector? We can see that it is equals to a vector. So we say that it would be equals to rho divided by 3 epsilon into a vector. That means net electric field would be just dependent upon, first of all it would be constant. Okay, at any point it is independent where we are locating this r vector inside this cavity. So it is independent of r, first thing. Second thing here is that it is just depending upon a. Okay, so if we see, and this value is constant, E is uniform and its magnitude is independent of r2, but its direction depends upon r vector. No, there is no r vector in this formula, so how can it depend? So first option is wrong. E is uniform, magnitude depends on r2, this is wrong. It is depending upon a vector. E is uniform, its magnitude is independent of a, but direction depends upon a. So so the direction is depending upon a. Direction is just along the radial location. Okay, so we can say that the direction depends upon the a vector. So this statement would be our correct statement. Now E is uniform and both its magnitude and direction depends on a. Now this is so this is basically correct and this is incorrect. Okay, because it is depending upon a. Okay, we can say that this statement is wrong. Why? Because magnitude is independent of a, but here we can see that magnitude, if we check in this expression, magnitude is depending upon a. So the correct option in this case would be our D option. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.